Here it is, guys. Entry one of our last unit, acids and bases. And we're just talking about characteristics today, because many household items are acids and bases, just connecting this to daily life, talking about what makes them special from a chemistry perspective. So here it is. I mean, look at us. We made it, guys. Last unit of the year. Who would have thought that this is what it would look like, but we're doing it. This is one of my favorite gifts of all time. So, anyway, moving on to acids and bases. You got the notes online. There's a little bit of characteristic info there. And then we'll just go from here. So acids are compounds, and I'm going to start with a broad stroke here. What we talk about with acids and bases are one definition of acids and bases, and it's kind of the most narrow definition of acids and bases. The reality is acids and bases are broader than compounds that just start with hydrogen for acids or for bases end with OH. But for our class, that's all we're talking about. Realize if you were to study beyond this in chemistry, you're going to get a broader definition. So anyway, acids are compounds that start with hydrogen, or H. So if I see H in front, it's an acid. The one exception, water. That hydrogen is usually bound to an anion, which is a nonmetal or a polyatomic ion. So backside of the yellow periodic table we got this here, the negative stuff. So does this mean that acids are ionic or covalent? Because H is a nonmetal, but it's also a +1 sometimes and bonded to a nonmetal. And actually this makes acids ionic compounds because we get a +1 crisscrossing with whatever the charge of your anion is. So what happens with acids is that when you put them in water, say I have hydrochloric acid here, I got an H and a Cl. I put them in water, the H and the Cl dissociate or separate. So I get a hydronium ion when mixed with water or base. So I put these in, they separate, and that H oftentimes bonds with H2O to make H3O+. So H plus and H3O+, because of that, mean the same thing, or an acid. So this example you should write into your notes. Like if I put HCl into water, I get H plus and Cl minus. And it's that H plus that often gives it the prototypical acid characteristic. We call those protons a lot of times. So protonated water would be acidic water because hydrogen has one proton and one electron most often. So if I remove an electron to make a +1, I'm left with a proton. So that's a unique characteristic of acids. And that obviously gives it its characteristics here. So acids have a pH, which is a scale of how acidic or basic something is, below 7. They're sticky and tart or sour. I don't know what I was about to say. But just imagine like peeling an orange. Afterwards, your hands are kind of sticky, and the oranges often taste a little bit tart or sour, or lemons. Citric acid is a primary acid in citrus fruits, right? There's a connection there for you. So these ionic bonds are in a lot of food products just in general. They produce H plus in water. They turn blue litmus paper red. So litmus paper is a way we could test where something is at on a pH scale, and they react with the base to form water and a salt. So different acids here, HCl, hydrochloric acid, sulfuric acid, or phosphoric acid. Normally we'd spend a lot of time going over how to name and formula write these, but we're going to focus on some different pieces with acids and bases this year. Because guess what? We're learning online and we're running out of time. So anyway, bases are compounds that end with OH. If I were to look on the back of my periodic table, I would find OH in the polyatomic ion, and it's called hydroxide. So that hydroxide is usually bound to a cation, which is usually a metal. So does that mean it's ionic or covalent? If you're guessing the trend here, it means they are ionic. So the metal is a positive charge, OH is a negative, not crisscross. So just like acids, when I put a base such as sodium hydroxide into water, I get sodium aqueous, meaning it's dissolved, and hydroxide aqueous, meaning that is also dissolved. But unlike with with acids, you don't really get an additional option. So H plus can join with water to make H3O plus for acids. For bases, you just get OH minus. Sometimes that OH minus could pull an H plus off of a water, but that would leave OH minus off on that other one as well, so it doesn't really work the same way. So an example here, you just have to write this one down when I want to talk about this one. So here, sodium hydroxide and water, I get water, sodium, and hydroxide, right? Or you could remove the two waters here because it's the same on both sides and see just like we did with our acid one. Now when I mix an acid and a base together, and we'll get this together, get this a little bit later, notice what happens to the H and the OH. They make water. And then the Na and the Cl form a salt. So really we get water and a salt formed in an acid-base reaction. So properties of bases, their pH is above 7, they're slippery, and they're bitter. And instead of things that you commonly eat, unless you're really into that Tide Pod challenge, ionic bonds are in cleaning products. So things that we tend to not ingest. But please don't eat Tide Pods. That's really, really dumb. You can die. So produce OH minus in water or acid, and in an acid that OH minus, just as we saw here, would join with the H to form water. Red litmus paper turns blue instead of blue turning red. Acid's red, base is blue. They react with an acid to form water and a salt. Notice here, you have your metal and then either one OH, two OHs, or three OHs. You could go back and watch this video, Properties of Acids and Bases. I would strongly recommend that. You don't have to. I'm not going to spend time to watch it on a video lecture on YouTube. That'd be like Inception video lecture. Maybe we should do that. Or we're watching YouTube on a YouTube video. That'd be crazy. Anyway, not going to do it. So one thing to note here, I'm going to start here, then I'm going to go back. So the pH scale. First thing is that when I see these brackets here, that means concentration in molarity. So our last unit solutions, acids and bases are solutions, and their concentrations are expressed in molarity or moles per liter. So when I see the brackets here, it's saying that the concentration of H plus is greater than OH minus below 7. And over here, concentration of H plus is less than the concentration of OH minus. I have more OH than H over here. And in the middle, H plus and OH, the concentrations are the same because at pH 7, it's a neutral solution. It's just water. Okay. So this pH scale from 0 to 14 is a logarithmic scale. Technically, you could have negative pHs as well. But this means that the difference between two numbers, it isn't a difference in concentration of 1. It actually means 10 times difference. So if, say, right here, it was 2 molar, if I went that way, it would be 20 molar, 200 molar, and so forth. Every number I went down times 10. So this direction is 10 times more acidic, that direction 10 times more basic for every number you change. Similarly, if I had a base at 11 versus 13, a base at 13 is 100, or 10 times 10, 10 times, or 100 times more basic than a pH of 11. Is that the most important thing in the world? No. You should understand this principle pretty significantly, though. This idea up here. Now let's just make it into a heart, because why not, right? Boom. Hopefully your heart isn't that shape. Oh my gosh. Okay. So pH scale, this is just a little review. That means concentration of that ion. So at 7, they're equal because I have water. When I go from 14 to 0, my concentration of H plus is increasing. When I go from 0 to 14, my concentration of OH minus is increasing. So just think about this. Where's highest OH plus, where's highest OH minus, and where are they the same? So this is just a general idea. You'll see questions similar to this on your quiz. So anyway, moving on now. H plus increases, OH minus increases that way. So that means here, this is number 1. That yellow is really hard to see. Highest OH would be 2 over here. And then number 3 is going to be right there at pH 7. So, true or false? pH of 11 is more acidic than 13. So 11 would be right here. 13 would be over here. Let's think about these things again. So anytime I'm moving this direction, it becomes more acidic. It's still base, but it's becoming more acidic, so that is true. Yeah. pH of 4, which is about right here, we'll say, is more basic than 1. Yeah, anytime I'm moving this direction, I get more basic, so that is also true. And what is the change in concentration? Anytime I go one spot, it's 10 times. 2 spots would be 100, and 1 to 4 would be 1, 2, 3, and 4. So that would be, give me 1 second, actually a change of 3 pH values, so it would be 1,000 times more basic. So last ideas here. When we put acids and bases together, what we get is, I got to change the color of that pen. That was driving me crazy. Forming water. So here, the main idea is that OH and this H come together to make HOH as one of my products. Okay, this is also water. Written as HOH, it's easier to balance though. So the first product is always water. That should be the easiest thing for us to remember here. And then the anion from the acid, so the Cl and the Ba are also going to go together. The metal is always written first, so I get barium crisscrossing with chlorine. Because barium's a 2, chlorine's 1, I get BaCl2. Now that should tell me that I need to put a 2 here to balance, and then a 2 there to balance. So that's really the main idea here. Plus, and then over here we have a second product up there that we didn't do yet. So water is always one product of an acid-base reaction, and the second one, the cation and the anion, are making the salt. So basically, if you can pick out water as one of the products, you're probably going to be okay, because I'm not going to give you lots of different crisscrossing options here. I just want you to be able to say, like, well, I know water's a form, and the barium and the chlorine got to go together. As opposed to barium going with H or something like that. So we can always say that an acid and base reaction, the products will always be a water and a salt. We got to crisscross charges in order to write the formula of the salt. Not going to be a major focus for us. The vocab here is that acids neutralize bases, or bases neutralize acid. And all that means is that when we mix them, their pH goes towards 7. That's the main idea here. So there's entry 1 homework here. Really what you're doing is going through saying HCl is an acid, base, or neutral. I would really love for you to pause right here and try these, and then I can go on to the next page really quick and go over the answers. So pause really quick. And next page. Yeah, you can pause here to review your answers really quick. So here starts with H, acid, slippery, base, pH below 7, acid, turning paper red, that's acid, drain cleaner, that's a cleaning solution, that's a base. Water is neutral. Water is neutral. Lemon juice, acid, H plus, acid. Lemon, H plus. Water's neutral. Water's neutral. OH is base, bitter, base, sour, acid. And that's it. Your quiz is going to be a mixture of those things on Friday. Let me know if you have questions. Love you, miss you, and I don't know. Keep it real.